In this video, we're going to talk about lists inside of STL. So the first type of list we encounter is a vector. It provides random access to any of the elements. It can grow in size as needed. It can use any algorithm of the standard template library. Now, here are the pros and cons. Adding or deleting elements at the end of the vector is pretty fast. Adding or deleting anywhere else, fairly slow. Searching for elements in a vector is also pretty slow. Access time for elements of the vector, very fast because we're directly. So an array and a vector look very much alike, although we have to include vector. Vector is defined in STL as a template containing a type name allocator we pass through as another type, and then a class vector. So how do we use it? First, we using namespace standard, and then we say vector type my vector. We can ask for an iterator by calling begin. That'll get us a pointer to the first element, or a smart pointer to the first element. We say vector int iterator. So here we give the type of the container, and then the word iterator, it equals my vector.begin, semicolon. The iterator doesn't equal my vector.end. Notice it's not less than or equal. And then we increment the iterator. Here we can display it by dereferencing it, so it really is a smart pointer. Begin returns an iterator pointing to the first element, and end returns an iterator pointing to the end element in the vector. So if you indirect the last element, or if you indirect my vector.end, you will get an error. Empty returns whether the vector is empty. While my vector.empty isn't true, add all the elements from the back, as in get the backmost elements, and then delete the backmost element. We can get our size by calling size. For example, size equals my vector size. So let's look at an example here. We also have vector clear, removes all the elements. So here we go. We include IOStream, we include vector, and we're using standard. So we declare a vector of integers, and we display its original size. Then we're going to push 5 values into the vector. Push back means push them onto the back end. Okay, we're going to display the size now. Access 5 values from the vector, as in we're going to walk through and display them all, and then use an iterator to access the values through 1 through 5. We're going to take a look at. So let's break it down. First, we're going to create our vector, and we're going to display its original size, which when we run it will say 0. Then we're going to create a loop and run through and push an item onto the back of the vector for each. And then once again, we're going to check the size. It'll now be 5. Then we're going to run through the loop and print out the values using just normal indexing. Okay, so we get 0 through 5. And then we're going to use an iterator. We declare the iterator, iterator over vector of int, v equals v.begin, get vec.begin, and while v doesn't equal vec.end, output the value, indirect access the contents of the pointer, and increment the vector, and then exit the program. So those are vectors, which you've seen before. There shouldn't be any surprises. So now we're going to talk about linked lists. A linked list is a data structure in which the objects are arranged in a linear order. Okay, each object contains a pointer to the next. Typically, the nodes of the list, each of the boxes, consist of data and a node pointer to the next node. The list simply contains a pointer to the first node. Lists don't allow for random access. You really can't just poke right in the middle. Inserting and deleting data does not require us to move or shift subsequent data elements, though. You can insert much quicker. It does require more memory, but it can grow in size as needed. So, adding or deleting elements at the beginning of the list is fairly quick. Adding or deleting elements anywhere else is a mix. Searching for elements in the list is slower, and access time for elements in the list is slower. So, when we want to insert into the beginning, we start at the beginning of the list. Then what we want to do is we first create a new node. The constructor, we say we want to insert 3. The constructor, here's our new node. The constructor inside and assigns 3 to it. So here's our value. And we want to put it at the front, so we take the head pointer to the start of the list and point it at the new element, and take the next pointer on the new element and point it to the previous first element. Or we could just take the pointer and assign it to next for here and assign head to look at that. Now say we want to insert it at the end. The new node's created again, and we assign 3 to the data. Null is assigned to the next pointer. Run through the list to the end, and change the pointer of 21 here, which are here, to point to our new node. Insert in the middle is a little trickier. First we create our new node. The constructor assigns 3. The pointer of new node is made to point to 21 after we, if we want to insert in the middle. And then the pointer of 23 has to point to 3. And you'll be doing this for a homework assignment. So, and you'll be implementing it yourself. To delete an item from the list, we start at the head of the list. We find the item we want to delete. If we delete something from the beginning, and we simply take the head pointer and just move it to the next item. If we want to delete at the end, we have to go all the way to one item before the end, 21 in this case, make it point to null, and then delete the node. The middle is the trickiest of the situations. We have to go to the node before our node that we're searching for, take that node's pointer, 23's pointer, and make it point to 21, and then delete the node. Now, we want to get things a little more advanced. There's a concept of a doubly linked list. We have, now our head has a pointer, now our node has 2 pointers, one to the next item and one to the previous item. You can iterate in both directions. And your list still contains a pointer to the first node, although now it would also possibly contain a pointer to the last node. You can also have a circular list where the end of the list points to the beginning. And the object contains the first pointer. Now, something to think about here is, how do you know when the list is empty? It would be when the first and last are the same. So we'll do a little demo here. Over to it. So, very simply, what we're going to show here is also how to use the sort algorithm. I'm going to create a list, create an iterator to it as well. We're going to push 1, 2, and 3 on the list. And we're going to call sort, which is a function in STL. And notice here we include both list and CC type. This is STL's list because it has a built-in list, right? And then we do the sort and print it out. And then what we can do is we can use a custom comparison algorithm, first and second, and basically we can say, go through the characters and compare character by character for all lowercase. And then use that different sorting algorithm and go through it again, and we will now see a different sorting order. Okay. So that is a very quick introduction to the list in STL. The code is almost identical to how we do it with a vector, even though under the covers, the vectors and lists are completely different. Through a simple example of using a list, here we go. First, we're going to declare an STL list of type integer and an iterator point that will be bound to an integer list. Then we're going to run through and put in 5 items on the back of the list, grab an iterator pointing to our first item, and move past that first item. We're going to insert 10 after the first item. We're going to insert 2 copies of 20 after that. We're going to move back 1, insert 2 copies of 30 into a new list called, into a vector called myVector. Then we're going to take that vector and insert it into the list, starting at the beginning of the vector and going through to the end. Now we're going to just output the contents. So let's run it. And here we see, first we do our inserts of 1 to 5, and we move past the first item. Okay, then we insert 10 here. Okay, and then we insert 2 20s. Yes, you can't see it here though. Then we create a vector with 2 30s in it and insert it right. And then we take 1 step back in our vector, create a list with a vector with 2 20s of it, insert it between the 30s between the 20s, and then we go and run through and display our loop. So that's a high-level introduction to creating items in a list. Now we have our remove. This removes elements with a specific value. Sort sorts the element in a list, altering their positions within the container. So sorts the element in the list using sort, altering the positions. You can also send in a comparison method, and it lets you specify how comparison works. So this would be an example of a comparison method. Right? Here we go. It basically does a no-case compare, character by character, and if you get to the end, then it just returns which one's longer. And here's just an example using it. And so basically that covers a high-level introduction to lists.